last topic in Activity 3.2 covers growth rate and the growth rate formula. So we've been dealing mainly with B, which has been the growth factor, and now I want to introduce R, which will be the growth rate. Right? B in the previous cell phone problem was 1.25, so our growth factor in that cell phone problem was 1.25. But what about the growth rate? Okay, so we want to discuss this in detail. So if we scroll down a little bit, we will see this formula, B equals 1 plus R. Again, where the B is your growth factor and the R is your growth rate. So if I know the growth factor, I can solve for the growth rate. If I know the growth rate, I can solve for the growth factor. And if you look at example 3, they give you a function, f of x equals 17 times 1.03 to the x. The growth factor would be the 1.03, that's my B. So if I'm looking for their growth rate, I'm looking for R. So I know what B is. B is the 1.03, I sub that in. I solve for R, so if I subtract 1 from both sides, I'm left with 0.03. So R equals 0.03 or 3%, right? We can change 0.03 as a decimal to 3% simply by moving the decimal 2 places to the right and adding a percent sign. So the growth rate for this problem is 3%. If we look at example 4, we're given the growth rate. So we're given R. We change the growth rate to a decimal, which is 0.024%. Right? We move the decimal 2 places to the left and remove the percent sign. And we're looking for the growth factor. So we substitute 0.024 into R, and we solve for B. So we simply just add 1 plus 0.024, and we're left with B equals 1.024. So given a growth rate of 2.4%, the growth factor would be 1.024. So in problem 7, we're given a growth rate of 8%. We're asked, what is the growth factor? Okay, so again, we can use that formula, B equals 1 plus R. And we can substitute the 8% in for R. So 8% as a decimal would be 0.08. So let's take stock of what we know. We know that R equals 0.08, and we know that B, well, that's what we're looking for. We're looking for the growth factor, given the growth rate. So when I substitute these values into my growth equation, let's see what we have. We're left with B equals 1 plus 0.08, right? I've subbed that in for R. And our final answer would be B equals 1.08%. I'm sorry, 1.08, not a percent. Right? So given a growth rate of 8%, our growth factor would be 1.08. Right? Again, we were asked, what is the growth factor? Our growth factor is 1.08. The next problem gives us the growth factor of 1.14, and we're asked, what is the growth rate? Okay, so we're going to basically go through the same routine here. We know that B equals 1 plus R, and we're given the growth factor of 1.14. So we know B is 1.1, and R is what we're looking for. So we can just substitute these parts into our equation. So I sub the 1.14 in for B, I'm going to solve for R. So if I subtract 1 from both sides, I'm left with 0.14 equals R, and we can change 0.14 to a percent by moving the decimal 2 places to the right and adding the percent sign. So my growth rate is 14%. Right? What is the growth rate? The growth rate is 14%. Last problem, number 8, it says, in 2000, the population of a town of Piro was approximately 42,300. The Chamber of Commerce claims the population is increasing by 2.1% per year. And then they ask us to write an exponential function rule for P of t that models the population of Piro. Or maybe that's Pyro. I'm not sure how to pronounce that. So again, I want to take stock of what we have. Right? We're going to still use this B equals 1 plus R. My rate, it's increasing, so I know it's a growth rate of 2.1%. We can change that to a decimal, which would be 0.021. And B is what we're looking for. So I moved this over here and I wrote my R equals 2.1%, or as a decimal, 0.021. Okay. So to find my B, or my growth factor, let's plug in these numbers to my equation. So when I say we have B equals 1 plus 0.021, we are left with B equals 1.021. That's my growth factor. Now we know an exponential model is that y equals AB raised to the x. Right? Y equals AB raised to the x. So in this case, remember, A represents your initial value, B is your growth factor. So the initial value, well, what's our initial population? Looks like the initial population is 42,300. So my A is 42,300. So I can write Y equals 42,300 times my B, we've already determined to be this 1.021, and that's going to be raised to the x. Okay, so that's my equation. Now, the book does say, listen, use T for x, right? T is going to be my input, x is my input. My output instead of y is going to be P. So perhaps we should rewrite the equation to conform to what the book is looking for. So I've rewritten the equation where I replaced y with P of t, I replaced x with t, and this is my final equation. So this would give me the population at any time, right? If I said, what's the population in 2005, I'd place a 5 in for t, because 2005 is 5 years after 2000, and I'd solve this equation, and that would give me the population 5 years later. If I want the population 10 years later, I'd place a 10 in for t, and so on. That completes the lesson.